Hello. 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 You can hear me?
Yeah, I can hear you.
Okay. Screen is visible, right?
Yeah.
So ultimately, this is the matrix equations to get the eigenvalue like this. So these are eigenvalue. Okay. So I'll tell you some now terminology which will be required in the next time. So just now, I mean, just we did in linear regression a straight line, and let's say in the classification problem, this we are going to discuss in the next class. So I want to introduce a little bit early. Um, so this is the three graph. One is called underfitting. This is appropriate fitting. This is overfitting. And let's say this is a classification problem, and there are two samples only. Two type of data are there. So if I do it in a straight line, if I try to separate out the data, what happens? So there are misclassification. You can see around 35 to 40%. Right? So too simple to explain the variance. So the variance is very high, and the error is very high. And here it's called appropriate fitting, because although there are some outliers is there, but the tendency of the graph is to fit is very smooth. The graph is smooth and it gives a very good result. It indicates the accuracy will be getting around 80 to 90%, as well as this is called appropriate fitting because the graph is smooth, and in future also with new data on the same pattern of the same features, when you supply, you can expect the results to be of same. The overfitting is that where the algorithm, this is, we have not touched it, this is the SVM, which can take any shape. So this is the linear regression or straight line, anything can be do. And this is parabolic graph. So the parabolic can be also used in support vector machines that we are going to use, explain in the next class. So this is the graph also, it can create by SVM. So this is, if you see, it is right during the testing time, how much the accuracy will come, 100%. But this we don't apply in our actual problem, because this is known, because the pattern graph doesn't have any pattern. It goes like this, and it understands how to accurately test the current data. Sorry, during the training, when the algorithms will get to know work. If you see, when the algorithm works during the fit, right? Any algorithms, when you work on it. So this is a linear regression. This is the other problem I cannot show you at the moment. So this is the fit method. When you do fit method with any algorithm, then what happens? So it creates a graph, straight line, or maybe as you say you got some, right? KNN, or you'll use whatever algorithm you use. Accordingly, it will separate out the data. So when you do the feed, so 80% of the data during that training, this graph will create. And let's say it is accuracy is 100% on the basis of this. So what will happen? This will, you give in the test data itself will be very good result. But when you introduce new data, the result is expected to fall tremendously. Because the new data, the data can be anywhere. This cross can be here. So again, it will not learn to do like this. It can only learn to follow a pattern like this. Two types of zigzag, and then again go like this. So the graph should be always smooth. Whether it's a straight line or it's a graph curve, it should follow a regular pattern. So this is also a overfitting curve. When it introduces, it solves all the problem. It separates out with that line. But what will happen when we have some more green objects here? So that time we don't know in the new data. It doesn't have it's a training graph like this only. So again, it can do like this only, but you don't know. So we don't prefer this kind of graph. So this kind of graph is assumed to be good, separate out as well as it's smooth, and this is also good unless but this is too much generalization we did. At the moment, you can think of like this only, this one graph. So this is underfitting, this is appropriate fitting, and overfitting. Overfitting graph is it can solve, or during the training time, the accuracy can be very high, but when you introduce new data, the result can go tremendously down. So, for example, so this is the data set. So this is the cancer data set. So, and I think we already did, right? So we already checked this thing. So let's say this data set is there and the algorithm gives very good accuracy. But let's say we have applied the algorithm SVM and where we predict it to give output accuracy like a 95 or something. But what will happen when we again wanted to predict? What will happen when we again wanted to predict with some new data instead of this test data? The production environment. So in the overfitting graph, we cannot expect the accuracy to be again a 98%. So that's how the graph with overfitting is avoided. Now, when the overfitting will be created? So overfitting is only created by mostly SVM because the SVM has only, a complex algorithm that it can get into any shape to fit the data. So we must be careful in using SVM that it should not get into overfitting. Now, how to reduce the overfitting? So that we'll go to the fundamentals. So let me see if I can introduce some basics. We have left some time. So only 5 minutes left. So you tell me any questions on it now, overfitting, underfitting, or so any questions on the overfitting side?
So like one question, Jimmy,
Pardon?
with the graph which you showed, where the overfitting term you showed, like whenever we predict the data, is there a way
When?
we can see whether our data is overfitted or it is underfitted in form of a graph?
Yeah. So this kind of overfitting. So I could not understand. Again, today's your end voice something issue. So overfitting will happen mostly on the SVM, and SVM can also solve complex things. So that will introduce the theory next time. So to reduce the overfitting, we have certain parameters we can control. So we keep the C and gamma value. You can see in this algorithm, we keep it low. The more if you increase, you see in this diagram, it tries to separate out the data very nicely, but it doesn't follow a smooth pattern. So we keep it the low end. So I could not, understand the questions properly. So is it that?
I send you a message.
Okay. So when you speak on one sentence is good. When you are talking about a long sentence, something is breaking out. Maybe the
Okay.
voice is, I don't know.
I send you the message, so you can check it.
Okay. Yeah. So this is This is where the graph we can create it. So the overfitting graph, how to create it means at the time of when you train the data only, that time you're getting the more accurate, you can print it and see it's overfitted graph or not. Yes. So this kind of graph we can create using a matplotlib. This will indicate your overfitting size or not. So that we will do. And generally, if you see, if you use a linear regression, you don't need to put a overfitting. You don't need to check. As I said, the overfitting tendency is in SVM because of which complexity can be increased due to the problem. But in linear regression, if the data is complex, you cannot. You cannot afford to change the graph, right? Let's say this is a linear regression. Whether the data is how it is, but we cannot change it, right? So we cannot get a overfitting value. And
Right.
so, but if you apply SVM, so it is too smart to get to touch all the points. Like you see in this one, snow ski, you will touch all the points. But then it's our duty to see it's underfitting or overfitting. I mean, regular fitting or overfitting. It's underfitted. And a regular fitted is like this, is a parabolic graph at this point. So we should understand that parabolic should only fit on it. So the next class we will be using SVM, and we will be using this kind of graph and seeing how its position changes. So will be SVM is used for regression and classification problem both, and SVM is also good for image classification. So and we will see both problem how we can solve regression problem. The regression problem we earlier did in linear regression only. So the next class we'll do with SVM also, and SVM for classification also. And then we'll apply PCA and SVM together and solve problem. Okay, so Amit, tomorrow you want to take the class?
Yeah, I can take it.
Yeah. Okay, so tomorrow 4 o'clock is fine or 3:45?
We'll do 3:45.
3:45. Okay. Okay, fine. So Saturday you are not free, right?
Saturday I'm not free now. Sunday I can do it.
Okay, Sunday is not required. Saturday. Okay, tomorrow we'll take up then.
Okay.
Fine.
Well,
See you then tomorrow.
Bye.
Bye.